Okay, everybody, this is chapter 10, section 2. This is simplifying radicals. It's a big math idea that you'll need for next year in algebra and geometry, and we'll use it for the rest of this year. Okay, so I'm going to do a couple of other little things that are review that go back to what we learned about in exponents. Today, we're going to skip one section that deals with the quadratic formula. I didn't teach you that yet in chapter 9. I'm going to do a separate kind of thing with that a little bit later, okay? So a couple definitions here at the top. A radical expression is going to be an expression that is going to contain something that will have a square root symbol. So, we've kind of talked about that in the last couple of chapters, but remember, it's going to look, something like this. And that's asking me, what number times itself gives me the value underneath that square root. Okay. Other rule that we have to deal with in this particular chapter or section is rationalizing the denominator. Okay. So remember, the denominator is the bottom of a fraction. I can't have a square root symbol down there. Math rule doesn't allow me to do that because square roots sometimes can be a number that really doesn't work, so we have to rationalize that, so we have to get rid of it. Okay, so they're telling me in this that I have to multiply the top and the bottom of the expression by whatever that radical is. So that we do that near the end of this section. Okay, one thing we're going to do is learn how to kind of simplify certain radical numbers. Okay, so we're going to learn how to simplify numbers that are not perfect. Okay, a couple different ways to do this. So you have to be good with your number sense. We've talked about that before, but I'm going to teach you two different ways. It can get kind of confusing here, and I'm going to save the last one and do a little bit later and kind of do a little review with you first. So just with numbers, there's two ways to do it. I want to factor this or get two numbers that multiply to 48, but one of them's perfect. So we kind of talked about those before, and I want a big one, as big as I can. So I'm going to kind of do this one for you. I know that 16's perfect, and 16 times 3 gives me 48. Okay, so the square root of 16 is 4, and 3 is not perfect, but I've simplified the square root of 48 down to that. Okay, another way is by a factor tree, and it should say prime factor tree, and some of you guys might have done this before, and I've shown you this on a couple other occasions. I just get two numbers that multiply to 48. Doesn't matter if they're perfect or not. And I'm gonna pick 6 and 8 because there's lots of choices for 48. I'm just gonna pick those two. It doesn't matter which one I pick. But 6 is, I'm looking for prime numbers. 6 is not prime, 8's not prime, so I'm gonna keep going. And I know that 2 times 3 gives me 6, and both 2 and 3 are perfect or are prime. Okay. 8 is not prime, but I know that 2 times 4 gives me 8, and that 2 is prime, but 4 is not, but I could factor 4 down to 2 times 2. So now what I've gotten is all prime numbers left over, okay? What I want to do now is go back and find pairs of the same factor, like this 2 and that 2 is a pair, so I want to take one of them, so I'm going to take a 2. I also have another pair of 2's right here, so I'm going to take one of them, and I'm multiplying all these stuff. Factors are multiplication, okay? But I come back here, and this 3 I could not pair up, so I'm going to put it back underneath the radical sign, and then I go 2 times 2 is 4 times the square root of 3. So I got the same answer two different ways. I strongly kind of want you guys to get to this first way I showed you, but sometimes we're not really understanding how to get there, so there's another way to get there. A little bit more complex, we'll have to think a little bit, takes a little bit more time. But remember, number sense, look to the biggest perfect square as a factor, and then what might be left over, okay? So going back to this 32, I know that 16 is perfect again, and times 2 gives me 32. 16 being perfect, I get 4 times the square root of 2, and that's simplified, okay? All right, I'm going to stop here for a second, go to a blank page, and kind of do some review with you guys a little bit. If we went back to chapter 7 and we looked at variables with an exponent, we would, to be able to take the square root of something like that, remember it's something times itself. So if I looked at x, you know, what exponent would I use to, in this case, multiply to itself to get 6? Now remember, we added exponents when we were multiplying. So what number would I really add together to give me 6? Well, it would be 3 times 3. Okay, so when I take the square root of that, I really just get x to the 3rd because it's the square root of x to the 6th. Exponent really adding to itself to give me that square root back here. Okay, so hopefully you remember that a little bit. Another example would be if I had x to the 4th. Well, if I had to take the square root of that, it would be x squared times x squared, because I add the exponents. So therefore, if I'm taking the square root of that, I just get x squared. Okay, so hopefully you remember the rules that when you multiply variables with exponents, you want to add the exponents. So I'm looking for what number would I add to each other to give me whatever the exponent is in the square root. Okay, another, just let me do one more. If I had something like x to the 14th and I had to take the square root of that, well, that would be 7 plus 7 gives me 14 in my rule of exponents. So the square root of that is really going to be x to the 7th. Okay, so we got to remember that rule. Hopefully you do. So I'm going to go to another blank page and kind of then show you what you have to do when things aren't so nice to us. I might get something like x to the 7th and have to take the square root of that. Okay, now what happens here is that I can't really do that because I can't get x to the 3.5 and x to the 3.5. They have to be whole numbers. So what a little trick is to split this up into x to the 6th and x to the 1st. Okay, I can take the square root of x to the 6th. It would be x to the 3rd. But I can't take the square root of x to the 1st, so I'm going to leave it. All right. So another little example then, if I had something like x to the 15th, and I had to take the square root of that, we'll take 1 away, split it up, and then I can take x to the 14th because that would be x to the 7th, but I can't take x to the 1st, so I'm going to leave it, and that's simplified. Okay, so I want you guys to get a little clue here. Both of these exponents were odd numbers. I took 1 away. That left me with even numbers, and I can just, you know, cut those in half, and that's how I got from 6 to 3 and 14 to 7. I just cut them in half, and that's the square root. Okay, so that's just a little thing that we got to kind of use as we go forward. Okay, so I'm going to go back to this question that we had to do and kind of use that. 63 is not perfect, but I could split that into the square root of 9 and the square root of 7. And I could then take this x to the 3rd, I could take it as x squared x to the 1st, and then I could do all my stuff. So square root of 9 is 3. Square root of x squared is x to the 1st. And then what's kind of nice with radicals, if I can't take the square roots, I can go back to everything that was not able to be, you know, square rooted. I can go back and kind of mash them together through multiplication, okay? So that's a little tougher question right there. It will be a test question, and hopefully we could practice this a little bit more, okay? Or look at my notes and use that. Okay, so moving on. All right, so we're simplifying these different ways to do this. You could use your factor tree. I'm looking for numbers that are perfect squares, though. I think that 16 goes into 160 10 times. And square root of 16 is 4. 10 is not a perfect square, and there's no factors of 10 that are still perfect, so I could leave it like that. If we remember our numbers here, another way to rewrite this too is that square root is really for the top and the bottom. So the square root of 64 is 8. The square root of 49 is 7. And we could leave it like that. If you remember back to in chapter 9, sometimes when you take the square root, remember it was plus or minus. That's kind of appropriate here for this stuff too, but only when it comes out to be whole numbers like that, all right? If I was taking the square root of 72, I know that it's not perfect. I look for a biggest perfect square. It happens to be 36 times 2, and the square root of 36 is 6. So that's simplified. Okay, I don't need to stick it into my calculator. We want it simplified. It's a big thing we do in geometry, so I want to make sure that we're teaching that here now. Okay. All right, so we'll come down to here. These get a little bit tougher. What I'm going to have you guys do is just try these on your own. So hit the pause button and give it a shot. A couple of these are a little bit tricky, but just please give it a try, and then I'll put the solutions up. Okay. Okay, we're back. So I put the solutions up for you. We had an odd exponent out here on the 7th. So if you had that odd exponent, you want to go ahead and take 1 out. So that's what I did here. The square root of x to the third is going to, or x to the 6 will be x to the third. Square root of 9 was this 3. And then I had this 6 and an x that was left over. I couldn't do anything with it, so I put them all together right there. Okay. This one a little bit more complicated. If you remember in your exponent rules, if I had the x's in a fraction, I could take out powers. So when I took out a power of 1, it disappeared down here, and on top it got x squared. Also, the 8 and the 50, they had a common factor. I took out a 2 from each. So don't let the radical keep you from remembering that I can reduce this fraction. So that's what I did. The square root of 4 is 2, and the square root of x squared is x. So that's how I got the top of this. And then the square root of 25 is 5. Okay. Over here, I broke up the 80 and the m to the 9th. A lot of stuff going on there. 16 times 5 is 80. I took that m to the 9th and I made it m to the 8th, m to the 1st. The square root of 16 is 4. The square root of m to the 8th is m to the 4th. So remember, when I put these back together, there's an m to the 1st right out here too. So that's where I got the m to the 5th. I put the m to the 4th together, m to the 1st together. I had a square root of 5, a square root of m left over. So just kind of mashed everything together. So those are questions you got to be good at. So hopefully, practice that a lot on your assignment for this section. Okay. Okay, going here, these get pretty tight with kind of what we're doing. Lots of different ways you could do it. You got to know your numbers. So I'm going to do these for you. I got to pause this so I don't run out of time on my video. So I'm going to do all of them and then kind of briefly talk about them. Okay, here's the solutions for these ones. What I did was I just multiplied everything together, just like regular numbers. So if I had a number outside the radical, I multiplied it. If I had it inside, I multiplied it. I also added exponents if I had them. And then I just went back and square rooted everything that I was able to, and then left everything that I could not underneath the radical sign. So those are ones that we could probably talk about at another time. On the other last couple pages, I'm going to do something a little bit different, so that'll be on a different video. Okay.